Hi everybody, solving paper 2, version 1, June 23. Define power, rate of energy. Prove that power unit is like that. Power equals energy over time. Energy, force times distance. Force, mass times acceleration. Mass is in kilogram. Acceleration, meter second minus 2. Distance is meter. And over time means second minus 1. You can reach this intensity of sound. Determine unit of K. So we will rearrange first, having K on this side. Okay, and on the other side I over F squared A squared V. So I is the intensity, which is watt over meter squared or meter minus 2, because intensity is energy per unit area per unit time, over frequency is second minus 2, A squared, meter squared, V meter, second minus 1, all of this in the denominator, so they can be first reduced to this, and after that goes up to numerator by reversing the power, and once again we can reduce, and what can be expanded, kilogram meter squared second minus 3. This is the unit of power given here, but we should not forget to okay, you can make the final reduction here to find the final answer, like kilogram per meter cube, which is unit of density. Here is a rod, a weight, a spring, and string. Okay. Compressed spring exerts 8.2 upward. Okay, other forces are labeled in the figure. Show vertical component of tension is 2.4. Here is the tension force. Analyzing it in horizontal and vertical direction means 4.2 sine theta, because the vertical component here has the far angle of 30. How to determine weight by using the momentum around the hinge. So forces of weight of the beam and weight of the block and the vertical component of tension, all of them are in one direction, and in the other direction we have the upward force of the spring. So 8.2, and here is the perpendicular distance 0.5. Weight has this perpendicular distance, so it's 0.5 plus 0.1, 0.6, 0.3, and here is the sum, and 4.2 the vertical one with all of the sum of these distances, we can get the weight. Horizontal component of force exerted on beam by the hinge. So this horizontal component must equal the horizontal component of the tension, because we have the beam in equilibrium. So it is tension cosine 30. We have elastic potential energy for spring, and we need the compression. Elastic potential energy equals half k x squared, or half f x. So by rearrangement, we have 2e over f equal to x, and we can substitute easily and find the answer. String is cut, spring extends upward, beam rotates, launching the block into air. Block reaches its maximum height and then fall back to the ground. And the figure shows part of the block before it hits the horizontal ground. Block is at height 0.09. When it passes through point A, kinetic energy given here at this point, when at the point B where block hits the ground, was the decrease in gravitational potential energy. So the decrease in GBE will equal the increase in kinetic energy, okay? And as we don't have the velocity at A, we cannot say how much increase in kinetic energy here. So decrease in gravitational potential energy can be given directly from delta GBA equals mg delta h. Delta h here will be 0.09. This distance, this vertical distance, will be 0. Okay, mg is the weight of block, and it was given as the heading of the question to be 0.3. Was the answer sorry, and using conservation of energy determine speed at A. So here we can apply that delta GBE equals delta KE. We calculate delta GBE, but delta KE is equal to kinetic energy at B minus kinetic energy at A. So delta GBE plus the kinetic energy at A, we can rearrange this equation to have kinetic energy at A as kinetic energy at B minus delta GBE or delta KE. Okay, and after that kinetic energy at A is half mv squared equals, as I said, kinetic uh, energy at B 0.044 given also in the question here. Okay, kinetic energy at B minus delta GBA or delta KE that we have just calculated. This number, as it equals to half mv squared at A, we can certainly rearrange by multiplying by 2, dividing over m, and the same on the other side. So here is the rearrangement, and after that we certainly should take the square root, okay, to have v here, and square root for this side. Here 0.3 over 9.8 because we don't have the mass but we have the weight. Y horizontal velocity remains constant because as the block moves in the air, only the force of gravity that affect its motion. There is no horizontal force, so no change in horizontal velocity. How vertical velocity changes with time from A to B? Certainly it will increase, and this increase in a straight line because it is motion under the effect of gravity, so there is an acceleration of g, and for a constant acceleration we have a straight line vt graph. Okay, so as we see here, b how it is changing with time, and we can see that there is a straight line, there is an increase in B, so delta B over T, which means the force is a constant force here through this portion till the 4 seconds. Okay, after that B has only single value, so there is no change after the 4 second in momentum, and hence no force. Okay, no resultant force. Newton's second law, force proportional to rate of momentum. At t equals 2 seconds, magnitude of force will be the slope, and we can get the slope here. Here is the first point 0 and 0, and second point 3 and 2, or perhaps 6 and 4, whatever. It will be 1.5 after all, 1.5 Newton. The force X, if we looked here to the diagram, we have a force X in a direction, and the other force which is not drawing is the friction. Okay, frictional force exerted on block by surface is constant. It has magnitude of 2. Okay, so 1.5 is the difference, is the resultant force, so it's the difference between x and 2, and here is x, which is the driving force, 3.5. Sketch graph for force with time. So we will have certainly some change around the 4-second time point. Before the 4 second, as we saw, there is a resultant force, which means that force X, the driving force, is greater than the frictional force. So we had some resultant force, and for this reason the BT graph of this resultant force was a straight line, okay, with a positive slope. But after the 4-second time point, we saw how the resultant force equal to 0 and momentum has a constant value. So with respect to force X, it will equal to the uh, friction, such that no resultant force. And as the friction is 2 Newton, we have X here 2 Newton. Okay, shows that rho g h equals the pressure at some point inside the liquid. Pressure equals force over area. Force is the mass times g, and the mass is given by the rho as rho times v. Okay, here is rho equals mass over v, mass over a flitch. K is the cross-sectional area of the beaker, and h is the height uh, or the depth of the point under the surface of the liquid. Making a rearrangement, you can say that A equals m over rho times h. So we'll change A here in this equation by m over rho times ch. Okay. We also were able to change m here by rho times v or rho times a times h, and hence a will be eliminated with a and have rho gh. If we choose to change the area, we will go as I wrote here, and again when we substitute a by m over rho h will goes from denominator to the numerator here, and uh, after elimination we got the answer. Why is this expression not suitable for total pressure? Because we must take in consideration the atmospheric pressure, and we hadn't. Okay. How we can determine the density of the liquid? First of all, we should get the slope of this graph because this is the graph between B and H. Okay, depth X. So this is the H, and B is H gives us uh, rho times G, and we know G, so we can know the rho. Here's a cylinder tied by a rope, and we make its bottom just touch the liquid surface. We have the cross-sectional area of the cylinder, length of the cylinder, tension in the rope. Calculate new tension. So first we should know that when we make the cylinder touch the surface of the liquid, we will have a force that goes upwards, the upthrust force, okay? And this will certainly goes against the weight of the cylinder. So we will have two upward forces and one downward force. Before we make the cylinder touch the liquid surface, we have the tension in the rope is equal to the weight of the cylinder. But as the cylinder now touches the liquid surface, we have tension in the rope reduced because we have another force that goes in opposite direction to the weight, which is the upthrust. So let us see force, upthrust force equal rho g v, okay, because B equal rho g h, B equals force over area, so force equal rho g ha, which is rho g v, okay. Substitute for them all. Density of liquid, we proved it, or we found it before to be 760. G is given. V also can be given by substituting here this value and this value. Okay. And the new tension will be the previous one, which is the V2 minus the upthrust force. Okay. This difference is the tension in the rod, sorry, in the wire. Okay, we have electromagnetic radiation with wavelengths around 8 micrometer. In which region? In IR region. Frequency can be calculated from relation C equals lambda F. We have the C, we have lambda, can get F. And after getting F, question wants it in terahertz. Tera is 10 to power 12. So when we get something to power 14, should be uh, multiplied by 100 and putting the symbol T. Okay, here is arrangement for interference. We have wavelengths of light. We have also slits and screen separated by we have distance across 8 bright fringes. Light emerging from two slits are coherent. What is meant by coherent? They have constant phase difference. Calculate separation between slits. We know that lambda equals x over d. So a equals lambda d over x, lambda 6 times 10 to minus 7, d d, which is the separation, was given by 2.8, and x is the distance here, 22 over 8, okay, because it should be the distance between the center of the fringe and the next spot, okay, and certainly multiplied by 10 to the power minus 3 as we goes from millimeter to meter. Fringe B is the central fringe or spot. Fringe Q and R are nearest dark and the nearest bright fringes to right of B. Calculate the difference from each slit to center of Q. So as Q is the nearest dark fringe to the brightest one or the central one, we have the difference in distance will be lambda over 2. Okay. Phase difference for fringe R, again the nearest bright fringe, which means order of 1, so it will be 360. Okay. Wire with length cross-sectional in the number of electrons. These electrons carries 172 coulomb, passing in 2.5 minutes. Show the density of free electrons is. So we will first divide the number of electrons, okay, over the volume of the wire, which is the cross section times the length here. After that, how we get the drift speed, we will apply the relation I equals N, electrons density times A, cross section, V is the drift speed, and Q charge of one carrier or the electron. Rearrange I over NAQ, I 172 over 2.5 times 60, okay, and after that we can easily calculate V. So here is the I calculated, and over N, also calculated before, A given Q 1.6 times 10 to the power minus 19, battery to resistors and thermistor, current and resistor 5800. Okay, we will apply Ohm's law, so we need potential difference across this resistor. Okay, over the value of the resistance, we can get the current in the resistor. So how we can get the voltage across? Voltage of battery is divided over these three resistors. Two of them have 6 volts, okay, which is the reading of the voltmeter. So remaining from 9.6 is 3.6 volt here on this resistor. So resistance of thermistor, there are multiple approaches to this. I choose to first get the voltage drop across 400 ohm resistor. So I got the current from the previous step, and these three resistors are connected in series, so it is only it is the same current that flows in the three. This current, if we multiply it by the 400 resistance, we will get the voltage drop across it. Okay, and we have this to be 6, which is a total of 2, so we can get the voltage drop across the thermistor to be 3.9. Okay, so we have here voltage across this thermistor, and we have the current, which again is the same across the three resistors, so we can get easily the resistance of thermistor. Okay, energy stored in battery. How it will be changed if a charge of 330 transferred. So we know that E equals V equals E over Q. V is the potential difference or the voltage drop, and E is the energy in joule, and the Q is the charge. So if we want to know the energy stored after the charge transfer, we should get first the energy drop that corresponds to voltage drop when a charge is transferred. This can be get by multiplying the voltage times or the EMF times 330, so we get the energy drop, and this energy drop will be subtracted from the initial energy, so we get the final energy in the battery. Okay. When temperature of thermistor increases, the resistance decreases. Okay, and vice versa. When the resistance of thermistor increases, temperature decreases. And as the resistance in thermistor increases, the wall resistance of the circuit increases, and hence the current in thermistor decreases because the whole current in the circuit decreases, and it is only one single current, so in thermistor current decreases. Potential difference will increase because we have three resistors and the potential was divided according to the ratio between the three resistances. So when one of them increases, the potential will increase too. Potential difference will increase too. Okay, nucleus X decay to Y by alpha if Y and Z are isotopes. How Y compares to Z in terms of charge. They will be the same because both of them are isotopes, and isotopes have same atomic number, same chemical element or chemical properties. So how Y compares to X, it will be less because X is the parent nucleus and Y is the daughter. The parent loses two protons, two neutrons, which is the alpha particle. So it loses 2 from atomic number, 4 from mass number. So with respect to charge, it decreases when we go from X to Y. Y less than X. Why Y cannot be stationary after decay? Because from conservation law of momentum, we have that momentum before equals momentum after. Momentum before is zero because we have one single nuclei, which is X, and it was stationary. Momentum equals mass times velocity, so momentum equals to zero. And after, at the alpha particle goes in one direction with some momentum, we should have the uh, daughter nucleus Y in the other direction with same value of momentum, and we can certainly say that velocity of alpha will be greater than that of Y because we have mass of alpha is less than mass of Y, and we should have both momentum equals and in opposite direction.